Thank you. That was really good and excellent to hear that the Arduino machine learning kits were being used for great projects. Are there any questions for Brian's group?
I have a question here. Emmanuel and Brian, did you, first of all, congratulations. I mean, the work is interesting because I saw several works with such kind of implementation of machine learning with this kind of game, using images more common, or including light, because the variation of the light when you have your user hands. To be very honest, it's the first time that I saw using accelerometers or emus, to do that. Did you implement it, or did it was not clear for me if you guys did the inference at the end using the device? It is one. And second, I would like to understand if you capture the data straight and enter to the network, or you did a pre-preparation, like is normal with kind of time series data. You have a window, a slice window, to capture pieces of the data as an input for the tensor. It's my two questions. I don't know if it's clear. I don't know if they are available, but I can. They can answer by writing after, no problem.
Is anyone from Brian's group got their mic on?
Hello, everyone. I'm Silvia Sotelo. I
Hello.
am a part of the equipment, the group, and a leader of this project. Well, at the moment, we obtained the algorithm in Colab and transform the TensorFlow model to TensorFlow Lite. Okay. Actually, we are prepared short trials in the context of the experiment. And in this moment, we need to refine this algorithm. The window we use actually in this moment it's 376 samples. Then this is the time to do the inference, because it is the context of the experiment, because we have a record 1, 2, 3, 1, 2, 3, piedra, papel o tijera, and then we show the movement in each case. Then the advance in this project is actually objective of the group, and then we need improve the results of the deployment. But actually, it works in Arduino, and the inference at real time it's possible. Okay. But the results are not good at the moment.
Okay, thank you. No, but it's very interesting, very good idea.
Yeah.
Any other questions for this group? And it would be nice to get some feedback whether those kits is something we should try to get the companies to donate again. They aren't. Is that true, Marco, at the moment? There are no kits being
unfortunately,
yet?
there are no kits. Yeah. But as you say, Jeremy, if we can show that the kits were useful, then we have higher chances to get more kits for donation to universities. Yeah.
Any more questions for that last group? While waiting for questions, we do have a very last group in the chat there. It's I'm not good at pronunciation. Jialu, Wan, Youngwoo, Edward, or Aquib. I'm not sure if any of them are on this call at the moment, if they could put their mic on, that would help. Marco, do we have a video from them or not?
We don't. We don't.
Oh, okay. Okay, so I think what we should do is open things up to all of the presentations today. I find after 10, 15 minutes, sometimes I have a question. And in this way of doing show and tells, you often don't get a chance to do that question unless you're on the Discord. Can someone place the Discord link on the chat just so people know that one? Are there any questions for any of the presenters today? Tiago with the efficient, the layers where he was training the different layers, which was really interesting.
Jeremy,
Yep.
there is one specific question here about Luis Lopez is regarding the last presentation from Colombia. It's Luis Lopez wants to know what's the hard part of the implementation of their projects. What they consider the hard part is the data set, is the implementation. So Sylvia, if you...
Well, firstly, the experiment, prepare the experiment and take the time with the students to make take the mixtures, firstly. And second one is to connect with Collab, prepare the model, but obtain the model with the best size useful to Arduino. Sometimes we obtain models, biggest models, but when transformed to TensorLite, we obtain some problems, and then we need to rethink about the structure to be more simple, because I guess this is the challenge at the moment.
Now, this I don't want to add to what Sylvia said is really, I think in my experience with the TinyML projects and also with my students at university, the deploy is the most challenging part. I mean, you have a lot of tools and a lot of ways, to get data, to clean data, to pre-processing, to do the training. You can do this use several different tools. Mainly people nowadays a lot of TensorFlow, and after that you can convert to TensorFlow Lite and also to TensorFlow Lite Micro to do the deploy to the device. In this last step is a lot of change. It is very, very challenge. Depend of how your model is structured, etc. Because you have, let's say, you find general information about that. It's more specific for very specific embedded engineers to do that using TensorFlow Lite Micro. For example, the book that Gianmarco showed us Monday is a very good example because, for example, he explained very well a few examples or a few projects to use TensorFlow Lite Micro. If you try to avoid that, of course, nowadays, the tool that you have on hand is the Edge Impulse Studio. This part of Edge, the most, I think, addition to Edge Impulse Studio to the TinyML environmental is exactly the last part of the deploy, because you can also you do all your job, using Python, as you are used to do, like Gustavo showed us today, and use their library to do that. Or you can use the studio to do all the process and also the final implementation. So really, still today, the final implementation, the deploy of the model to the devices, I think is the most challenging part of a TinyML project.
Okay, yeah.
Jeremy,
Any
back to you.
other questions? People can just mic up. Oh, something in the chat.
Yeah, so maybe this question from Josue could be for Luigi, I guess. And it's about neural processing units and TinyML. So it says it's new in the field. Can someone provide an overview of their application and available resources? So in your paper, have you stumbled in any project that use NPUs?
Yes, we found some project that that use NPUs, but was project that was not specifically tailored for TinyML. So are more in general project that propose efficient implementation for efficient implementation for the given task. But what we saw is that the use of both MPU and also tensor process unit on edge devices, like for example the Google Coral board, is very increasing over the last 2 years.
If
You're muted, Marcelo.
I want to jump a little bit. I put in the what do I see nowadays? It's is I starting to use neural processing units. Like for example, CD Studio launched a couple of months ago a very interesting and very cheap device. They call the AI image V2 or something like. And I put a link for some experiments that I did with that. It's amazing. It's very fast, very cheap, and they are using the new ARM CPUs, the Cortex M55 plus the NPUs, the U65, I think, if I'm not wrong. It's fantastic, and you can use that. You can use that to implement several TensorFlow-like models, including you can use for YOLO models for image classification, for pose detection, etc. So I think NPU is a reality in our world of such kind of devices, and the consumption of such device is amazing. It's less than 100 milliamperes. So I mean, it's really a device for using in the TinyML spectrum. I think Jeremy is also using with his student. No, you did some experiments, no?
It's really, really interesting. We're using the Grove Vision AI V2 is the important part, and it's ridiculously fast. I have this vehicle that runs with the Portenta H7, and it runs at a walking speed, and it can sense the little track. But this one is about 12 times faster. But the funny part, I just went to grab it. There's the Vision AI, there's the whole car. The analysis sends so fast to the servo motor that the servo motor is shuddering and can't handle it. So this is one of my things with machine learning on these reduced capacity devices is you've got the machine learning, but you also have what you want it to do, whether it's an actuator, the sensors, whether it's IoT. And so that's a big part of the time I spend is not just the machine learning model, but the extra steps. And in this case, it's a servo motor that's failing for me to use the extra speed of this Vision AI V2. Yeah, it's interesting where machine learning is going on these miniature devices.
If you agree, I have a real-time demo here. And yeah, that's recognizing me in real time. So the way it works, as Marcelo said, there's some pre-existing models. So person detection of different sort, face detection, gesture, hand pose, pet, strawberry, apple, blah, blah, blah. And now I'm doing the pose, human pose, which, as you know, is a very time-consuming process. Yeah. And you see if I'm moving, it's recognizing my pose. And this is, if you look at the log, it works at quite high frame rate. So yeah, again, quite amazing for a device which is sold for like $15, I believe, or
Yes,
something like that.
less than that, Marco. Less than
Less
that.
than that. Yeah,
Yeah, I think $30 or something. Yeah.
yeah.
Yeah, it's very
That
nice. It's
SenseCraft, that SenseCraft site is pretty impressive. The Chow ESP32S3 that has the camera, you can take models off Edge Impulse as long as they're int 8 quantized and load them directly on it. And they have their preset models. The Grove one is a little more complex, right, Marcelo? You have to take an Edge Impulse model and then convert it. Is that correct?
Yes, you convert it with Vila. That is a special for exactly to handle. In fact, is to use all the power of the neural processing unit that you have in the Grove V2. That's what Marcus show is amazing. I mean, amazing. I remember a few years ago, I used a Raspberry, a very powerful mini computer, let's say, to do pose estimation. And now we can do pose estimation with a few dollars device. You know, it's, I mean, that's because the neural process unit. So as Josué asked, I mean, the NPU is more and more being used in real applications for TinyML. And not look, another thing interesting is not only the hardware itself. For example, Jeremy is also did a lot of experiments with his students. With he showed us for example, the SP32S3. But for example, one of the things that we don't have a NPU by hardware in such kind of device. The ESP32S3 is on a normal NPU. On normal CPU. But nowadays, companies like Expressive, the company that run or create this device, this CPU, they are using or they are delivering neural networks libraries that can, enhance the ability to run TinyML models or machine learning models very fast. So nowadays you can have image classification, you can have object detection using, for example, FOMO, more precisely, very fast for real applications. So this is, and also sound. So this is another good achievement that you have today is neural network accelerators by software and by hardware.
Any more questions for people? Because we do have time and I have a presentation that I can show. But let's get the questions out. There's a kind of a last call to the detection in medical time series models presentation. I don't see those people online. If any of them are, please put your mic on. Any other questions? There's a question about something with a app for smartphones. Smartphones, in my opinion, are a total different world. TensorFlow.js is incredibly powerful for smartphone work. You can just make a web page and access it with your smartphone and do all YOLO, pose estimation, hand estimation. Smartphones are quite a bit more powerful than most of the ESP32s that we're using.
For smartphones, I think that Google has very interesting tutorials, free tutorials. You go enter to Google, you enter about phones. They have tutorials to explain how to implement or how to develop projects using smartphones. So you can also you can use some simulators during the course, and also real implementation. Mainly with not with Apple, but with Samsung, some Android devices. There is a Marco. There is a book, a very good book, about the phone implementation from our friend from Google.
Yeah, I will post a link in the chat in a second. Yeah.
Okay.
In the meantime, there was one more question that is TensorFlow better than PyTorch? So maybe you can comment on that.
Well, Look, both are very similar. Those are Python libraries. I also asked to Diego, that's a doctoral specialist in this field, to talk about that. To be very honest, I have more experience with TensorFlow because TensorFlow Lite, TensorFlow Micro is very useful for TinyML. PyTorch, but for example, I'm doing now experiments with LLMs, like a ChatGPT running in Raspberry. We should use PyTorch for that. So the libraries that are more specific for such kind of development is PyTorch. I mean, both are good. I saw that recently PyTorch is growing, I think, maybe more faster than the TensorFlow. PyTorch, for what doesn't know, it's a library, it's a framework from Meta, correct? And TensorFlow is a framework from Google. But I mean, both are open, both are work very well. I don't know. I think academia like to TensorFlow, like more PyTorch, and the industry more TensorFlow. I don't know, Diego, if you have something more to add to that. Diego Mendes. I don't know.
I don't know. I always think that you cannot just use one single library or one single framework to solve all the problems. I guess that's the thing. So when you have a more powerful device, such as the Raspberry Pi, and you already have an embedded Linux running, you can use different libraries like PyTorch and using Python right there. But TensorFlow Lite, and especially the TensorFlow Lite Micro that we normally use, is really useful when you're using microcontrollers. So I guess there's no single unique answer for that. You just need to learn where and when and on which devices you can use a certain library. I guess that's, yeah, there's no single hammer to solve all the problems. Yeah.
Someone in the audience, this is a very good debate. I mean, some of the other researchers or have some experience. I would like to talk about PyTorch and TensorFlow for machine learning.
And especially, Marcelo, you said something that really important on the previous presentation, that the most difficult step that requires the biggest effort is to actually deploy the model on the device. So you can actually train with many different frameworks, but at the end, if you already know how to use a library really well and it's working on the device, normally you keep on using that one, even though there are some newer ones. So that's why I guess some people like ones and some people are other libraries. Yeah.
The good thing is both are free. It's all open. I mean, open, free, and they can use. That's the good thing about PyTorch and TensorFlow.
Yeah.
Now, Marco put the
yeah, I mean,
book.
the book is there, but Lawrence gave a talk in 2021 in the first series of this workshop. So the slides and the video are available. I added the link here. Yeah. Okay, any other questions? So if there is no more questions, we have some time for Jeremy to
Yes,
present
and it's going to
your
be a little
project.
awkward because my students are going to start coming in and knocking on the doors. Sure. Let me see what we've got here. What I presented in Italy last summer was a way of doing web serial to communicate with your devices on the computer so you could see your data and things like that. If you've got a cell phone and you want to scan that QR code, it'll take you to, let's throw it on the chat too. It'll take you to a site that you can use your cell phone IMU to make a model. And last year I did this, and yeah, it was interesting, but you can't, last year you couldn't put the final model you made back on the device. And this year I've bumped it up a little bit, and you can actually put that model you create back onto the device, but kind of like the Grove Vision AI V2, you then have to go to another site to convert the model. In my case, I'd have to load a Python site to convert the model from TensorFlow.js to TensorFlow Lite, and then a C header file. What I have at the moment are these very, very interesting LoRaWAN sticker trackers. They're $14, and I have a class set for my high school kids. And I should be able to connect this, and live performances are always fraught with issues. But here's the main page, and on your cell phone, you'd see the main page. And what's interesting with the cell phone is you can do exactly what I'm doing, but collecting data. And so first, I just want to zip through and connect my device. Hopefully that's all there. That kind of looks right. And there, I'm getting acceleration data XYZ. So if I was going to try to train this, I would first clean it. I always put numbers in front of labels. So this is just the device lying flat, and I'd keep that. And then I'm going to wiggle it a little bit, do another. The results are looking kind of strange, but I'm going to keep that one. And I'm just going to get 3 samples. And this is something VJ brought up a while back, that with these microcontrollers, we have the potential to see every single step. And this is one of my dilemmas with using a site like Edge Impulse, is suddenly I can teach an entire group of grade 10s in about 40 minutes how to do a vision model. And it worries me how much they understand. Now, I'm not doing a vision model. I'm just going to turn this on its side, see if I get different data. Sending it. That is not looking like different data, but I'll show you the steps. And so the concept here is that I can then convert this data over to tensors and then train it. And this is not looking like it is training at all. On your cell phone, you could do exactly the same thing and train it. Live demonstrations. Yours worked today, Marco. Mine's looking very strange. Okay, so assuming the model made and I could view my model, I could export that model. And this is the step that you would go to a Python notebook. So here's Python notebook. I ran the first 2 buttons. And so I should be able to just upload that model. And there are the models I made. I called them Fred. You've got a bin binary file and a JSON file that describes it. Upload it. And I think we just run this. So this is much like the site Marcelo's would take you to for the Vision Grove AI V2. And I believe there it is. It downloaded my model, which is now able to be run on your microcontroller. So let me just have a look at this model. Well, it'll make a C header file. So let me go back to this. I really like doing presentations that I've already run past my kids, my students, so I know things are going properly. So here's what we just saw, where it's loading data. And as you can see, that data is a lot better than the one I just showed today. There's the chart. This is all one web page. So if it works for you, the students could edit this web page and look at it. Now, this is on your cell phone, same kind of thing. You're designing it, and this is where it would show that it was working. And this is a step that didn't work for me today. It does work. So here we are on that site. I loaded the IPython notebook, and it saved that, and it converted it to a TF Lite, then converted it to a C header file. And this is the step where you would load Roxetta TinyML, which is open source taken from Eloquent Arduino, and it's a TF Lite before we started using Edge Impulse. Made it like 3 years ago. And in this example, oh, this one's got the Nikola motion, but I'm using the Rack 2270, but it'd all be the same. This is what you downloaded, is a C header file that has your model on it. And so that then you can run and install on, in this case, the Rack 2270 sticker tracker. What I've been working on is also putting LoRa or LoRaWAN on that sticker tracker. So it could sense, say, the vibration of a machine and then send that data over. And this is where things get complex because these are already constrained devices. It's amazing to get a machine learning model on the device, but then to now use LoRa or LoRaWAN, which uses a fair bit of the memory, it's difficult. So I managed to get LoRa on this, and I can send a LoRa message from multiple of these devices to a web page to view in that situation. The next steps are to have one of these sticker trackers take all that information from multiple machinery around the building and then send them to LoRaWAN, because that one device would just be a collection device. And that partially is working as well. Yeah, look at my data here. It's very strange. I wonder if I've lost a wire on it. Anyway, that's what I'm working with. The point here is for students to actually see all the steps. And this little black area is quite important because it's actually the entire model in JavaScript, which most of my students know. And if you look right here, anyone's familiar with machine learning, it's a sequential model. First of all, I flatten whatever data's coming. There's a dense layer of 8 nodes. There's a dense layer of 20. There's a dense layer of 30. And then softmax to get an answer based on what information's going in. So really simple for students to add an extra layer, update the model, and retrain it. And as I said, I've got lousy data coming in at the moment. But as far as my students understanding what's going on with a machine learning model, I like this approach. I love Edge Impulse because the simplicity, and we can do vision. Vision would be much harder. Here you would have to use convolution layers. So that's kind of the thing I'm going with. Last year in Italy, it couldn't be loaded back on to the device. Now it actually can. And the part I like is we're in control of all the steps. So if there is something you don't like, you could change it. This is one single web page. And I'm really sad my demo didn't work. I really want to see if it'll load. Let me just refresh the page, see if I get better data. So I'm connecting.
But your work is fantastic. I mean, it's very nice. This very useful. Yeah.
Yeah, it's that whole teaching, bringing the whole part, because it's so easy to skip over a part. Oh, now I'm getting data. Let me just run through. This was, I don't know if I cleansed that last one. Okay, I'm just going to cable came out. So yeah, once again, we deal with real issues with devices. These racks come with this, and it's really hard using one of these to do motion sensing devices. So the one that should have worked a little better today, look how horrible that looks. But they're actually soldered onto the pins, and much better for motion because theoretically you can move them around. What I probably need to do is not have those pins. So, as I said, these things are better when you ran them past students and seen what all the errors are. When it can train, I like that you can just do a few more. If you want to do a few more epochs, train it a bit more, and you should see the loss and the accuracy right there. I guess I could. No. Anyway, that was my presentation. We're at 8:40. I'm going to have students coming soon. Let me, if I can figure out how to stop sharing. If anyone's interested, here are all the links for that page. Did anyone manage to load it up on their cell phone? Because it is kind of fun. Yeah.
I did. Yeah, it worked. Yeah, my phone worked. Yeah.
And because the cell phone has less messy data, it actually works better than the real device. Now, this is a really interesting step with TF Lite. Messy data, it cannot stand. And so I have to have that clean the data part. But once you make the model and you have a model on the device, it's actually really accepting of bad data, which worries me a little bit because sometimes we don't know if the data is terribly clean going into our model. And so it's great that the model still chooses one of two options, but it's not so good realizing that if that model, that if that data from the sensor was really bad, it still would classify it.
And Jeremy,
that's- yep.
there is a question from Segun about your data, exactly about data. He wants to know if you can download the data that you have collected.
On the site, I believe right here, save CSV. And so it would give it a number, and you can, when you collect the data, save it. And I think that kind of, you started this, Marcelo. You mentioned Web Serial collecting data. And so I think that was the reason, was to get some data in CSV format so it was easier then to load onto Edge Impulse. And so, yes, you can get the data. And I think there's this button here in red, show file uploading. Yeah, you can upload data as well.
I think you're not showing your screen anymore. Yeah.
Oh, darn. Oh, darn. Oh, well. Yes, if you mess around with that page, there is not only saving data, but uploading data as well.
Okay.
I just got to open a door, and we have a bit more time for some discussion. Give me a second.
You guys have more questions about the presentations or about in general before we finish today?
If there's no questions, maybe we can call it a day. Oh, okay, Jose, please.
Oh yeah, I just wanted to share with you guys an interesting event that is going to happen on. I just shared the link on Zoom. So the European Space Agency is having this conference on artificial intelligence in and for space. So this is the first congress about related to AI and space. So if you have like any idea or project related to space, satellites or whatever that is in space and has AI, this is a really nice opportunity to share and to apply. So I just share with you the link on the Zoom chat. Thank you guys.
Super. Thank you so much.
Very
Okay,
good.
good. So I think we can call it a day. Great presentation today. Thanks again to all the presenters. Very interesting stuff going on. And we meet tomorrow, same time. We have an exciting day tomorrow as well. learning about some scientific applications, some papers that were published, and learning about, if you want, the dangers of TinyML. So the last talk tomorrow will be an interesting talk by Brian about what can go wrong with TinyML, or what we should think about in terms of privacy and security. Okay. Have a good.
Ciao.
Someone's mic'd up here. Do you have something to say?
Okay. See you tomorrow then.
Bye bye, guys.
Have a good day.
Have a
Ciao.
great afternoon. Bye bye.
Bye-bye.